by 4 over x minus 1. Okay, if you replace x by 1, what does that give you? What is arctan 1? I'm sure you know that. Tan of pi by 4 is 1. Therefore, arctan of 1 is pi by 4. Arctan 1 is pi by 4. So the numerator becomes pi by 4 minus pi by 4. And the denominator is 1 minus 1. That will give you 0 over 0. So you got arctan 1 minus pi by 4 is the numerator. 1 minus 1 is the denominator. And arctan 1 is pi by 4. So we get the form 0 over 0, which is the intermediate form. Therefore, we can apply the L'Hopital's rule. And what is that rule? Limit x approaches 1, arctan x minus pi by 4 over x minus 1 is the same as limit x approaches 1. The derivative of this, the derivative of the numerator is simply the derivative of arctan x. Is that right? Because the derivative of pi by 4 is 0. Alright. Do you remember what is the derivative of arctan x? Yeah, that's very important to know. So that will be the derivative of arctan x minus pi by 4 divided by derivative of x minus 1. And that is limit x approaches 1, the derivative of arctan x is 1 over 1 plus x squared. And the derivative of x minus 1 is 1. Well, this will be, what is 1 over x squared divided by 1? That is 1 over x squared. Can you replace now x by 1? So that would be limit x approaches 1 of 1 over 1 plus x squared. And when x becomes 1, the value of this is 1/2. Therefore, limit x approaches 1, arctan x minus pi by 4 divided by x minus 1 is 1/2. Can you do this graphically? Well, here we have the graph. As x approaches from the left and x approaches from the right, the value of the function approaches 1/2. And if you look very carefully, you can see a hole in the graph there. That means this function is not defined at x equal to 1. The function is not defined at x equal to 1, but the limit of the function as x approaches 1 from the left and the x approaches 1 from the right will be 1/2. All right. Another one. Evaluate the limit. Limit x approaches 0 from the right of e to the power of x plus x, all raised to the power of 1 over x. Well, is that an intermediate form? Well, we have an exponent here, and in order to do the derivative, we actually have to use the logarithmic approach here. So what we're going to do is, because we have a power 1 over x, we're going to call this quantity, this limit, let the limit be called y. So we say let y equal to limit x approaches 0 from the right, e to the power of x plus x, all raised to the power of 1 over x. Now, whenever we have quantities that are raised to the power that contains the variable, this is the approach that we need to take. So let y equal to this limit. Our aim is to ultimately find y, because what we want is the value of this limit. We call this value of the limit to be equal to y. Well, what happens if you take ln of both sides? Let's do that. Take ln of both sides. Take the ln of the left side will be ln y, And the right side is ln of limit x approaches 0. Is that right? So taking ln of both sides, we get ln y equal to limit x approaches 0. See, we can put that process outside ln. We can say ln of limit x approaches 0 of this quantity, which is the same as limit x approaches 0 from the right of ln e to the power of x plus x raised to the power of 1 over x. Alright, now when you have ln of a power, remember the power gets multiplied, is that right? Ln of x to the power of a is a ln x. So ln of e to the power of x plus x raised to the power of 1 over x is 1 over x times ln e to the power of x plus x. That's right. So that will be limit x approaches 0 from the right, 1 over x ln e to the power of x plus x. Well, this is the same as ln e to the power of x plus x divided by x. There you go. Now, this is of the form f of x divided by g of x. You can see our original expression was not of the form f of x over g of x. Now, if you want to apply L'Hopital's rule, the function, the expression has to be of the form f of x divided by g of x, and a direct application of the limit must give you 0 over 0 or infinity over infinity. Now, our original expression actually was not of f of x over g of x form, but by calling it equal to y and taking ln of both sides and simplifying the right hand side, you can see what the right hand side has now become. The right hand side is limit x approaches 0 from the right, ln e to the power of x plus x over x. This is now of the form f of x over g of x. Alright, if you replace x by 0, what do you get? Can you think of it? When x becomes 0, e to the power of 0 is 1, and this x will become 0, so the value inside the parenthesis is 1, but ln 1 is 0. So the numerator becomes 0, and the denominator, when x is replaced by 0, is also 0. So that is of the form 0 over 0. That means we can apply L'Hopital's rule now for this limit. And so, let's do that. Now, this is what we have. Our left-hand side is ln y. We are not going to touch it. We're going to leave it there. The right-hand side is this. And we just said when x is replaced by 0, this will be of the form 0 over 0. And therefore, we can use L'Hopital's rule. This will be the same as limit x approaches 0, the derivative with respect to x of ln e to the power of x plus x divided by derivative of x. Okay, and now tell me what is the derivative of ln e to the power of x plus x. Now try and write it down in a piece of paper, the derivative of an ln quantity. Remember, the derivative of an ln quantity is 1 over that quantity times the derivative of that quantity. Alright? Here the quantity is e to the power of x plus x. So the derivative of ln of this quantity will be 1 over that quantity, 1 over e to the power of x plus x, times derivative of this quantity. What is derivative of e to the x plus x? It will be e to the power of x plus 1. So the derivative of ln e to the power of x plus x will be, what will that be? It will be e to the power of x plus 1 divided by e to the power of x plus x. And the derivative of x will be 1. So, I don't know whether you can actually see this on the screen, but this will be limit x approaches 0. The derivative of this quantity, I'm going to repeat again, the derivative of this quantity will be 1 over the quantity. Let me write that down for you. Like this. The derivative of d by dx of ln e to the power of x plus x will be the derivative of a quantity. Now here, this is our quantity, ln of a quantity. Derivative of ln of a quantity is 1 over that quantity. Look at this. 1 over that quantity e to the power of x plus x multiplied by what? Multiplied by the derivative of that quantity. Now the derivative of e to the x plus 1, e to the x plus x is e to the x plus 1. So that gives you e to the x plus 1 on the numerator and e to the x plus x on the denominator. And that's what the derivative of the numerator is. Derivative of this quantity, that is what I have here. E to the power of x plus 1 over e to the power of x plus x. That is the derivative of this. And the denominator, of course, is 1. Okay. And because the denominator is 1, we don't need to worry about it. So that's the same as limit x approaches 0 from the right, e to the power of x plus 1 over e to the power of x plus 1. Can you now apply x equal to 0 there? That will be e to the power of 0 plus 1 over e to the power of 0 plus 0. That will be e to the power of 0 is 1, 1 plus 1 is 2, divided by 1, and that's equal to 2. Yes, that limit is 2. But have we found the actual answer? Well, we are looking for this limit and not this limit. Remember, this limit is ln y. We started this by taking ln of both sides. So this quantity we just evaluated, which gave you 2, is actually equal to ln y. So we haven't finished. So we have ln y equal to 2. Therefore, what is y? If ln of y equal to 2, then y equal to e to the power of 2. That's right. So we have y equal to limit x approaches 0 from the right of this quantity, and that gives you y equal to e to the power of 2. That means the value of this limit is e to the power of 2. And here I have the graph of that quantity. As x approaches 0 from the right, as x approaches 0 from the right, the value of the expression becomes e to the power of 2. This is actually e to the power of 2.